In this video, we're going to look at adding our ECS resources to our infrastructure as code. So far we've got our Lambda deployment, which is working, and we can see in our CloudFormation here in our stack we've got our load balancer and our Lambda deployed, and we're able to make requests to our load balancer and retrieve our response from the Lambda. So in order to get ECS working, we're going to need some resources, starting with the role. So we're going to need an IAM role. So we'll create a role for ECS to use. We're going to need security group, obviously. ECS security group. That group's going to need a rule. So we'll give that an ingress rule. We're probably only going to need the one in this case. We just got our HTTP endpoint that's being listened on. We're going to need task definition. So we're obviously not going to be able to start anything without a task definition. So we'll create a task definition resource. We'll need our ECS cluster where our task will be run under a service. So we'll put the cluster in, cluster, and our ECS service resource. And the last thing that we're going to need, obviously each of those instances that are deployed then need to be added to a target group. So we're going to need to define an ECS target group as well. Alrighty, so having a look at this role, first cab off the rank, I've got one that I've created earlier which I'll copy in given that there's a lot of boilerplate here. So in this role, we've pretty much kept the same standards that we've had for our Lambda. We've just added a ECS postfix here just for simplicity and to keep the two roles deployed independently. We've got the ability for our tasks to ship logs. Obviously they need to create a log stream in our log group that we've got deployed at the moment, and push events. The other thing that we need to do, same with Lambda, we need to authorize it to be able to actually access our ECR repository. So we've got ECR login here, and then we're also allowing it to go and pull and download the image layers from our repo that we've been publishing to. So not a lot going on here. It's more just enabling ECS to access our artifacts. So now I'm going to move on to the security group, the rule, and I need to also add load balancer. So we're going to have the rule here for traffic going into our application, which is going to come from the load balancer itself. And we're also then going to tie the load balancer's egress to this particular security group for our workload. And then that way we've kind of got a tighter footprint, I guess, around those particular resources. If anyone's familiar with microsegmentation, that's the practice of kind of just only allowing things to have that least privilege access. So we're going to tie the load balancer and this ECS service together, and that way neither will be accessing anything else. So I'm going to speed this up just to kind of get it out because it's only boilerplate, and I'll see you in a minute. Okay, so for this task definition, there's some extra bits and pieces here we need to cover. So there's a little bit of boilerplate. So here we're just defining our task family, which is, we'll just call the same as our repository. We've got our role ARN that we've defined. This is our role up here, ECS execution role. We're using VPC networking mode, so we're going to end up with an IP address in our VPC. Fargate, obviously, is what we're going to use to run this because we're not running our own compute behind the scenes. We've just limited it to a quarter of a CPU and 512 meg of memory, and we're going to target the ARM architecture, which is the same as what we've been using for Lambda. So we also need to customize the container definition, so we're going to add that in. So in our case, we've only got a single image that we're trying to run, so we only need to list one of these things. So it needs a name. That's going to be our repository name, which we've been consistent in using so far. The image is going to be the same one that we use for Lambda. We find our Lambda definition, we can take that image URI back down here, so that becomes the image that we're going to reference. This container is essential, so the reason that we set the essential flag is just to let ECS know that if this particular container exits, then the task is finished. And it's effectively critical. So if it's failed or anything like that, we need to terminate it. Now because we're running on an image that's made for Lambda, there's a few changes we want to do here. First one, same as what we did in our makefile on the previous video, we actually want to disable the entry point. So we can override that here. So entry point, and we just effectively want to blank it out, make it a blank string. We need to make sure that's capitalized. And the next thing that we want to do, because we're not giving it a Lambda handler, we want to give it the script that we want to run, and we created that previously, which is our start nginx shell script. So we'll set the command. It's also a list, nginx, because we copied it into the root of our container image. So start.sh. And we need to do some port mappings for this container. So it's going to have its own ENI given to it because this is a VPC networking mode deployment. So we only need to define the container port in this case. We're not mapping it into a host. So the port mapping, not a host mapping. Port mapping is the container port, which for our service is just running on 8080. So that one's nice and easy. And the last thing that we're going to need, well, obviously we want to be able to send logs somewhere, so we need ECS to be able to go and create a log stream and ship all of the standard out, standard error logs to that. So let's add a log configuration. So log driver, AWS logs. And we need its options. So we've got AWS logs group that needs to be defined, AWS logs region, and AWS logs stream prefix. So with these three settings, we can use obviously here our nice little helper variable that we get for the AWS region. So we'll take that one. Our prefix, we may as well just make it nginx. This will just mean it's really easy to understand what the different streams are, which one came from our nginx deployment on ECS and which one was Lambda when we're looking in CloudWatch logs. So we're going to have a look at that shortly when we do our deployment. And the group's going to be the same as what we have been doing. You can probably copy that straight from our Lambda definition. Back to where we were, log group. It's just our log group resource. Easy. Okay, so that's the task definition complete. Now we've got our ECS services. So the first one's the cluster. Now with these particular resources, I mean, what we've been doing to date is effectively just trying to deploy things to save money. So when we deploy Lambda, we've got all the resources we need for that. When we deploy ECS, we don't need some of the Lambda resources. Well, we don't really need any of them. and vice versa. So if Lambda's deployed, we don't need the ECS resources. Most things in here, things like security groups, task definitions, and things like that, don't really cost anything. Or even if there is a cost associated, it's quite minimal. ECS clusters are generally free. If you're using Kubernetes EKS, I think there's a minimal monthly cost on those, but nothing much. So for anything that does cost money, so running the service and the tasks, obviously we don't want those there. We're going to add a conditional that's going to allow us to ensure those resources aren't present when we've deployed Lambda, and vice versa, we'll refactor our Lambda stuff so that it's not deployed when we've got the ECS cluster deployed. So the cluster resource itself, given that it doesn't cost anything, we could leave it there, but I think it just creates visual noise inside the console. If you're looking at, you've got several clusters there that are performing certain duties, you probably don't want ones hanging around that aren't running anything. So we'll, just for convenience, we'll take that out. So the way that we're going to do that is we'll define some conditionals within our infrastructure as code here. So we'll create a new thanks VS Code. I'm not sure why we got that one. Conditionals. And pretty much all we want to know is it a Lambda deployment or is it an ECS deployment? That's what we're looking for. So we'll pass those in. So we'll create a new parameter for that. We'll call that deployment type. This will just be a string. This is our own thing that we're creating. Should give it a description. So it's just going to be the type of deployment to use. And we'll default it to Lambda because that's the one we've currently implemented, and it's also probably going to be the most cost-effective version. So we'll have that as our same default. We're also able in CloudFormation to define a set of allowed values. So given that we've only got those two conditionals, let's explicitly define that, and that way we'll get a nice handy error back to anyone trying to deploy with a value that we don't expect. So we'll define those allowed values. That's just going to be a list. So obviously Lambda is allowed, and then we'll just call it ECS as our other option. So we've got those two. So in order to use them, we're going to need some conditions in here. So Lambda equals, we'll just do an inline list of this stuff. So we're going to reference our deployment type, and if its value is Lambda, then that'll be our Lambda condition. And we have the same thing again. Might as well copy this. Same thing again for ECS, but obviously if we get our ECS value, then the deployment type is targeting ECS. So let's take that conditional. We'll come back down here where we're going to be working on our ECS cluster. So obviously we need to define our type for that, and we're going to define a conditional or condition, which is going to point to the conditional that we've got above for that definition. So let's put the type in. So that's going to be AWS ECS cluster. Got our condition. We need some properties. Cluster name and capacity providers. Probably the only things that we need at this stage. I'll just call this thing my cluster. There's no point putting ECS in the name of this. We know what it's for. Clusters are generally going to run many different types of services, so I'm not going to name it based on the single service that we're running. It seems pointless to have a cluster for a single service, so ideally this would be something we would reuse. You could use your default cluster if you happen to have a default cluster defined in your account. we'll just create this resource today. We're not EC2 backing, so we want Fargate for these capacity providers. So there is the standard Fargate provider, and then there's also Spot. So if you want to get some instances that are more cost effective and you can tolerate small outages, potentially if you're not able to get more Spot capacity during those times, then yeah, Spot's a good option to consider. So that's our cluster. So we've got our conditional in there. So only when we're deploying to ECS will we actually have this cluster available. And we're going to follow that condition through the next lot of services as well. And this is effectively just boilerplate just to link our existing resources. So I'll speed things up while I implement the ECS service and the target group. Okay, so that's our ECS service and the target group. So something to note in here, we've got, due to us using the VPC networking deployment type, we've had to set the target type on the group itself to be IP based. And something else to note is that I've assigned a public IP, and the reason for doing that is it was the simplest way at the moment to allow the Fargate instance to access the ECR repository. Otherwise, we need to have a more robust and complicated setup for our VPC itself. In this case, we're using the default account VPC, so I haven't provisioned that. Leave that as a separate thing to go and deal with in future. So obviously deploy this in a way that makes sense for your own use cases, but for simplicity today, we're just going to go with a public IP just to allow access to those services for convenience. Rightio, so that pretty much gives us the bulk of what we need. So down below, I've added an outbound rule for our load balancer as well, which is just saying that it's allowed to talk to our instance or anything within the security group, our ECS instance on port 8080. The target group's registered with the ECS service, and we've got almost everything that we're going to need. Let's move across to our makefile now. Given that we've now added deployment type, we're going to need to update our deployment scripts to be able to pass in that particular value appropriately. So if we go up to the top here, we'll probably want to default this, and we'll keep our defaults being Lambda. Obviously we do have a default in here for the property at the moment, but we'll just be consistent with that as we're defining our variables. So we'll create our deployment type variable, and we'll set that to Lambda as well. And then we need to come down to our workload, and we're going to add new variable in there for our deployment type. Just making sure we've got the case correct on that. Rightio. So that should allow us to pass that through. So if we were to run this makefile, how we've been doing it at the moment, we should find that we don't actually get any changes as we're just deploying our Lambda image itself. Okay, we've got some CloudFormation issues, so we can actually run out. We've got our deploy validate task, so we can verify that our templates are correct. So obviously we've got that error coming up, so let's have a look at that one. type's not aligned correctly, so we'll tab that in. Let's validate it again. We've got another problem, 147. Okay. Okay, so it looks like this is our culprit here in the naming of Mr. A colon. Let's give that another go. Conditionals is invalid. That's interesting. Because it's conditions. Okay, read the docs properly. That's important. Let's try that again. Okay, excellent. So now we've got a valid template. So if we test our existing deployment again, that should effectively just give us our Lambda deployment. Something else that we can do while we're thinking about resources that we need depending on the deployment type. So security groups don't tend to cost much. So when we're deploying ECS, we can keep the Lambda one deployed. That doesn't matter. IAM roles don't really cost anything either. So we'll keep the role deployed. They also take a bit of time, so having them deployed is always handy. Lambda itself doesn't really cost much. You just pay per request. So we'll let the function be deployed all the time. A or B permissions, just a setting. Target group. So target groups cost something. The load balancers and target groups tend to cost a bit of money. So let's put our is Lambda condition on that one. Is Lambda, yep. And that way we won't have to pay for the target group to be present for Lambda when we're not using it. Our roles are obviously going to get deployed. Security groups we don't mind. There's our rule for ECS. So even when we're deploying Lambda, we're going to keep deploying those. Task definition. ECS cluster. So obviously we've got our condition to only deploy the cluster and the service when we actually want ECS running. Same for its target group. Load balancer security groups we'll keep, and rules. Load balancer itself, obviously we use for both deployment styles at the moment, so we're going to keep that. Listener, so these are just load balancer settings, so no issues there. So our deployment happens, so if we switch across to our CloudFormation console, we've still only got Lambda. We should now have some ECS security, here they are. So we've got our execution role, so our IAM role's been deployed. We've got our security group with its ingress rule. We have our task definition, but we can see there's no ECS cluster or service that's actually running, and there's no target group defined. We've still got the Lambda target group. So that seems to be working the way that we expect. Excellent. We might run it again, given we've now added our condition in there for the Lambda target group to only be present when Lambda's defined. And we can see there's no changes to deploy. So even though that's an error, that's just what the AWS CloudFormation deploy command line does by default. You can actually turn that off and you can set it so it'll just be successful, which is handy if you're doing it in a build pipeline. Okay, so now back to our make file. So we're defaulting to Lambda. We want to be able to actually deploy our changes for ECS. Let's go and, so we've made a few changes. Let's go and stage those. Yes, we're passing our deployment type through. So there's our new parameter and our condition. We've got our condition to only have the Lambda target group when we need it. We've got our new ECS target group, our ECS service cluster with their conditions, our task definition, our security groups for ECS, and the role. Perfect. Load balancer egress rule. So this is when we're deploying to ECS. So this is allowing communication there. Great. Okay, so yeah, we're adding our ECS infrastructure code here, and we're updating our makefile that we're using for doing our deployments. We've just done a new commit, so let's go and build a new image, not that there's any change to that, so we'll just produce a new tag for it. We'll push that image up, and we'll deploy our workload. So we've done our Lambda, we've tested Lambda still being deployed, and we only got that delta, so this time around we want to actually deploy our ECS setup, and we'll expect that the Lambda target group has been removed. So we still want to run our make deploy workload, but this time around we want to actually override our Lambda default that we've got up here. So we want to set the deployment type, and we want it to be ECS, which was the option that we've defined in our CloudFormation template. So we'll run that, and this should generate a brand new change for us. Or fail, that's fun. Unresolved resource dependencies, Lambda target group. Okay, so yes, we've forgotten something. Let's get this out of the way. So at the moment we've got the single load balancer, but we've got two target groups, and we need to tell that load balancer when it needs to use each of those target groups. So at the moment we can see here, so this is our listener rule. The action to forward requests is currently pointing directly to the Lambda target group. So what we're going to end up doing now is taking our conditional that we've created, and we might use the multi-line style for this one just for readability. So the target group, we're going to use a condition function. So just an if, and this will be a list. So let's put our list in. So is Lambda. So if it is Lambda, we want to use the Lambda target group. But in this case, we're deploying ECS. So when it's not Lambda, we want to refer to our ECS target. ECS target group. So if we go back here, let's run our validate. We'll just check that our CloudFormation template is correct. Oops. Deploy validate. Nope, we've still got a problem. Unsupported function if. What have I done? Probably something with colons. Yeah, I've missed one. Okay, so there's a double one there. This is where linting and validation steps like this, especially if you're going to run it in a build pipeline, you've got multiple engineers contributing to this stuff, you want this validation just to know things are good before you go to do a deployment and find out everything's burning down. Excellent. All right, let's amend our commit. We'll add that in because we expected that to be there. We just forgot it. Unfortunately, we've got a new commit char, so we'll retag. We'll push that tag. Okay. Let's try this again. So make deploy, deployment type ECS. So this time around, we should have the correct target group for our listener rule, and we should find that in CloudFormation that we've actually removed the Lambda target group from the deployment. So we'll wait for our change set. Okay, there we go. So if we come back across here, we should see, yep, there's some changes happening. Our cluster's coming in. Let's look at the events. So our task definition has been updated because we built a new artifact, or at least we tagged a new tag on our artifact. Okay, we've got our ECS cluster, and we've got a failure. Awesome. All right, what blew up this time? Unfortunately, we don't get all of this validation when we use the AWS command line tools to validate CloudFormation stacks. Sometimes we need to actually run them to get appropriate feedback from services at runtime. Model validation failed. Okay, it doesn't like a key. Load balancer not permitted in network configuration for the ECS service. Okay, so I've probably got a key incorrect there. So if we switch back, we want to find our ECS service. Load balancer. It's a list. Okay, so it's probably plural. It'll be load balancers. Container name, container port, target group. Yep, the rest of that looks okay. Alright, so we're still waiting for the stack to roll back. I'll speed this up so we don't have to wait for it. And I'll amend our commit and run the deployment again. Okay, so now our stack's been updated. Managed to fix all those bugs I introduced. So we can see in here, we've still kept our permission resource. We now have our new cluster. We've got our IAM role. We have our security group. We've got our ingress rule to allow the load balancer access. Our ECS service is being deployed. We have our ECS target group, task definition. The Lambda is still around because it effectively doesn't cost as much of anything. Its IAM role and security groups are there as well, but you can see its target group is missing. The only target group we've got is the ECS one. Load balancer obviously is still hanging around, and our log group. So we should be able to request through our load balancer a new instance, we should service a new request of our React app directly from the load balancer itself, directly from the ECS cluster, if I get that right. So if we look in here, I think, oh no, we are seeing our server, so we can see that's come from Nginx. So it's not saying ELB anymore, which is what it does when we're deploying under Lambda. So that's excellent. If we jump in here, we can actually go across to our ECS cluster, and we can see that we've got this one service which is running a single task. If we jump in, I'm not seeing any graphs updated just yet. We can see all the deployment events, and if we check the logs, there we go, we can see Nginx is logging both our health checks from our target group and also the requests that I've made from a web browser. If we go over to CloudWatch, we should be able to see those logs are also in the same log group. And you can see down here, so previous requests that we've done from Lambda have those streams, and now our container instance or our service instance, the task ID that's being used in this particular case, with our Nginx prefix, so we can identify where our requests are being served from, which is pretty cool. So we can see our logs coming through from our script we created in the last video, and everything else is working as we expect. Awesome. So we should now be able to come back here, and if we want to, we can switch our deployment type back to Lambda, and hopefully, given that we're not deploying all resources, this should actually be much quicker this time around. Obviously, doing the ECS deployment is going to take a bit longer. We're using Fargate, which means we don't have compute running that we control before the task starts up. So we've got to wait for Amazon to provision that compute. In the case of Lambda, though, we effectively only need to deploy a target group. So we will see a number of events for cleaning up the resources that we use for ECS. So if we look in here, go to update complete, so we're creating our target group. We're seeing our ECS services now being decommissioned. It's not showing the latest status under resources. That's all right. I trust that it's doing the right thing. So there'll be some ECS instance draining for that Fargate instance as well. So we could adjust timeouts there, particularly non-prod, if we want to speed that up. In this case, it's perfectly fine. So we see our listener rules being updated and our target groups deployed. So even though this hasn't finished doing its cleanup, if we jump back over to our app and hit refresh, yep, we're coming from the ELB. So we're already servicing requests from our Lambda. So that's actually switched across really, really quickly, which is great. So there's not really much in the way of downtime, at least going from ECS to Lambda. Going the other way, let's have a look. Let's see what that does. I suspect that there will be some downtime, particularly if it's updated that listener rule. So if this is updated early before the ECS service is complete, then we'll probably see an outage there. We could possibly try and muck around with some dependencies between the resources that we're deploying to try and get it to only change that rule once the service is up. But in this case, we'll keep it simple and we'll just allow it to change as needed. Ideally with this, the whole point of this particular video series is just to kind of demonstrate being able to have one application that you're building, and we can either deploy it to Lambda or to ECS depending on what the requirements are. It's not that we would necessarily be constantly changing where it's deployed and be concerned about small outages or needing to do some kind of rolling update, I guess, for live traffic. So I think the biggest benefit we get from something like this really is in non-production workloads where we don't want to have things on and costing money all the time. So you might want to deploy it as a Lambda in your non-prod environments, and then only while developers are actively working on them are they actually sending requests, and you're paying for that, versus if it's ECS, then you're paying for the compute being on all the time, which might actually be something that you want in production if you're publishing a web app that's there 24/7. The other thing, obviously, we're probably not going to put a React application inside a container and run that. There's a few ways of doing it in Amazon. We could have, or we could, if we are using Lambda or S3 or something like that, so we could have an API gateway in front of it. Not the topic for this particular video series, but it's one way of doing it. If it's going to be something that's accessed publicly, static artifacts, S3 CloudFront in front of it would work perfectly. This particular use case gives us something that's nice that we can see in our web browser, which is where the static app is handy. If you've got constraints in your environment as well, so say you've got a really locked in internal VPC. Having CloudFront running S3 may not be a thing. If you don't have control over VPC endpoints as well, it can be very, very hard to kind of route traffic directly into S3 buckets. So there's a couple of example blog posts out there and on the Amazon blogs as well, where people have gone and implemented similar setup to this, where you've got an ALB and you've got a Lambda instance, which is then retrieving artifacts from S3 for you. If you don't have the VPC endpoints available or you're unable to manage them, then yeah, something like that is where this particular deployment style is easy, because you've got the ability to run Lambda with the load balancers. You can expose an endpoint and it'll go and access things. I guess in our example here, we've put that static application, all the files inside the Lambda itself, so it doesn't actually need to go and talk to S3 to go and get resources. So we've kind of just made our architecture a bit smaller as well. So if you're in one of those highly locked down environments where you don't have the ability to host static stuff via S3 and CloudFront, maybe you don't have the ability to use API Gateway with a private endpoint, this is certainly something that can assist. So there's a few use cases there where you may actually host static applications like React inside a container like this. But yeah, there's several ways that you can accomplish this on a cloud platform, and obviously anything through S3, you're only paying per request. It's very, very cheap as well, probably cheaper than using Lambda. Okay, so our stack is finished. We're still getting our requests here coming from Lambda. So let's switch that back and let's see if we get an outage while this change is occurring. I suspect that we will, just given how long it takes Fargate to spin up an instance, and that we're not controlling when that load balancer listener rule gets updated. Okay, so cluster's been created. So right now, listener rule's being changed, yeah. So if we go over here, we're still getting a response. Yep, still coming from Lambda. It's still working. Oh, no, we've broken something. Okay. What have we broken? We didn't even change any code. Target group. Well, the target group should get the associated load balancer. Okay, so I think the update was cancelled. Okay, so looking at this, we've got a bit of a race condition. So ECS itself is doing some validation on the load balancer, trying to make sure that the target group that its tasks are being managed by is actually what's being used. At the minute, it was still our Lambda, which, given it's rolled back, it still is. So given this runtime validation, it's probably worth our while putting in a depends on setting. So it was the ECS service that did that validation. So if we make it dependent on our listener rule, because this is what controls which target group's being used. So we want to make sure that that has been updated first. We're still waiting for our rollback. I'll speed this up for you. Okay, so we can see this time our rule's been updated before the ECS cluster. Yeah, 503. Yeah, that's what I was kind of expecting before. So while it's deploying the ECS Fargate instance, we're going to have an outage because we've now updated the listener rule ahead of the service being deployed. Given that the ECS service seems to be very particular about the target group being assigned to the load balancer, it's less than ideal for being able to flick between the two. Might need to think about another way that we could possibly handle that in a more rolling fashion. We could probably have both target groups applied even to our load balancer, and then just select which one we want it to use rather than the condition that we've got. And that may assist in what we're trying to achieve here. Okay, Nginx is up, great. So only a small outage. So if a rolling update's preferable to you, this is something we'll need to look into. If you're able to have a small outage window for a deployment, should you be switching between Lambda and ECS, if you're just doing an update, whether it's a change to the underlying Lambda function itself or whether it's the ECS task for the service being updated, you're not going to see that same kind of outage. This is because we're transitioning between the two different services that we're hitting that particular issue. Cool, so our stack's updated and complete. We're now back getting our responses from Nginx, which is fantastic. Great, so we might call it there for this video. In the next one, I plan on running some performance testing. So we're going to test our ECS task, which we've only got a single instance at the moment, only 512 meg of memory. Nginx is fairly good with memory, but a high request rate might cause it to possibly hit that limit. So we might see something interesting there. Lambda itself should be able to scale. Default accounts have around 1,000 concurrent executions, so it'll be interesting to see how we go there. And we'll see whether 1,000 concurrent executions in Lambda is actually, does that actually support more requests, more successful requests at a high rate than our single Fargate task. We can also scale our Fargate task up so that there's more capacity there and try and work out what that balance is. But we should be able to get some interesting statistics. So let's see that in the next one.